Today I've been doing a little bit of wiring. So what we've got here is basically a mini ring main, which consists of a socket which is outside, and this socket here is for powering whatever inside the shed. All that is connected to the pure sine wave inverter, which is bolted underneath there. And what I've still got to do is replace this cable here with the thicker stuff, because it's just a bit warm in this orange stuff, which is bigger, as it's barely warm, so I'm wanting to upgrade everything. This short length of 16mm squared cable is it's a bit hot at the end here, and that's probably due to the fuse or the connection. I'm not entirely sure. That's a 125 amp fuse, and I'm putting just now 60 amps through it. At the end of the circuit breaker here is it's quite warm as well, but so that wire is getting replaced with something thicker too. And the problem is, the wire that I ordered is a bit too thick. So look at it, this is 70mm squared stuff, and I thought that was roughly what the size of the high voltage cable out the Outlander was. I even measured it and everything and did calculations, and I end up with stuff that's thicker than a garden hose pipe. This stuff's absolutely huge. And I got it was about £18, and I got a meter of each colour. So this little thing here is a DIN-rail watt meter that I got from China. I'll put a link to it. And that LED on the front flashes every time a watt hour has been consumed. So it cannot be reset to 0, and it saves the value when power is turned off. But it's just unfortunate that there's no way of resetting it. Maybe the only way to reset it is open it up. I did see an EEPROM chip, and maybe reprogramming that. But yes, as you can see, it's like a ring main. We've got two 1.5mm twin and earth cables going to each socket, just like a ring main. But the only issue is I'm still getting the ground present light on my car charger not coming on, so I really don't know how to earth an inverter system properly. There isn't too much danger involved really, unless you come in contact with live and neutral at the same time with the inverter system. Because like with the normal mains, the neutral at the transformer at substation is actually connected into the ground, and that's basically how your earthing system works. There's a huge air spike at a substation, which is just the neutral goes down there, and then your earth works basically through that. So that's basically in a normal system. If live touches earth, that creates essentially a short which trips the RCDs in the house, because that is kind of like shorting live to neutral, because the earth in your house just goes into the ground obviously, and that's just shorting out, and that's effectively just shorting live to ground, because you've got the ground stake in the substations. And as you can see, it's just charging just now. I tried to find a socket with a neon on it, but the only way to get that would have been to buy one of these, and I already had this box here, so I've got one socket for my renewable energy source and one just for normal mains. And as you can see, I've not got the ground present light coming on. But yes, I'm still a bit unimpressed with that circuit breaker. It is rather warm, more up this end, maybe because the wire's thin, and that's only 16mm squared. I don't know what the high voltage cable for the Outlander is. It must not be 70mm squared, it must be a bit less. So here's a comparison between the two. so we'll just try and compare them. So Outlander stuff's slightly smaller, but all I've got left of that is this, which will form the negative cable going to my power inverter. And I don't know whether just to get rid of that 100 amp circuit breaker and then just rely on the fuse. I'm not too sure. The thing is, what worries me about this fuse is if it does blow, it might just melt in half. I don't know. I probably won't know, but eventually I'm going to have a cover across the entire battery bank, just in case I drop something metal. Because if I drop a metal spanner on this, possibly over 1000 amps can flow and the thing will just turn to molten metal. And those wires curled up there, they're only connected to the current meter, the analog meter, which is just a way up there. They're not actually connected to anything else otherwise. So it doesn't matter if they come into contact with anything they're not supposed to. So yes, that's my most latest wiring configuration. So back to this meter. I'm not sure if not being able to reset it is ever going to be a concern anytime soon, because looking at numbers, it's probably able to store 999,999.9 kilowatt hours. So I don't know, I'll probably be dead by the time I've produced that much. I'm not sure. But it also has an output, so every time that light comes on there's also a pulse that comes out, and you could probably connect that to something like an Arduino, and you could use that just to count watt hours, and or connect to a Raspberry Pi and just send that information elsewhere or whatever. But basically the shunt is probably in there somewhere, and your live goes in through connection number 1, and your live comes out again through connection number 3, that says. So in through 1, out through 3, and your neutral just goes into number 4, and that's just to power the unit. And you've got your other 2 connections up there for the pulse, and I think the pulse is about 20 volts or something like that. Anyway, I've put these up for sale as well for £550 on eBay, so they'll be collection only.